For decades, the idea of humans being able to survive in space has been a topic of science fiction. However, with recent advancements in technology and space exploration, this once impossible notion is becoming a possibility. If humans could survive in space, it would revolutionize the way we approach space exploration, opening up opportunities for long-term space missions and potentially even interstellar travel. This is Fantasy World. We try to imagine everything about your fantasy. The human body is not designed to function in the vacuum of space. Exposure to space without any protection would cause rapid decompression and result in almost instant death. This is because in the absence of atmospheric pressure, the gases in the lungs, blood, and tissues of the body would rapidly expand, leading to a range of health issues including ruptured organs and tissues. However, spacesuits have been specifically designed to counteract this issue and allow humans to survive in the harsh conditions of space. A spacesuit is essentially a mini spaceship that is worn by an astronaut to provide a life-sustaining environment in the vacuum of space. The spacesuit consists of several layers of material that provide various functions. The outer layer is made of a strong, durable material that protects the astronaut from micrometeoroids and other debris in space. The inner layer is a thermal insulation layer that helps to regulate the temperature inside the suit, preventing the astronaut from overheating or becoming too cold. The most important layer of the spacesuit is the life support system. This system provides the astronaut with oxygen to breathe, removes carbon dioxide and other waste products, and maintains a constant pressure inside the suit. The life support system is powered by a backpack worn by the astronaut, which contains a supply of oxygen and a system for removing carbon dioxide. The spacesuit also has other features that help the astronaut to function in space. For example, it has a communication system that allows the astronaut to communicate with mission control on Earth, as well as other astronauts in space. The suit also has built-in gloves and boots that allow the astronaut to manipulate tools and move around in space. Despite the advanced technology used in spacesuits, they are not a perfect solution for long-term survival in space. Spacesuits are bulky and restrictive, making it difficult for astronauts to move around and perform tasks. They are also only designed to provide a limited supply of oxygen and other life support systems, which means that astronauts can only survive in space for a limited period of time before they need to return to a more habitable environment. In order to overcome these limitations, scientists are exploring other ways of providing life support to astronauts in space. One possibility is the use of artificial gravity, which would simulate the effects of gravity and reduce the negative effects of long-term exposure to microgravity. Other potential solutions include developing advanced life support systems that recycle waste and produce oxygen, or developing new materials that can protect astronauts from the harmful effects of radiation. Radiation is one of the biggest challenges for long-term survival in space. The human body is not built to withstand the constant exposure to high levels of radiation that is present in space. The Earth's atmosphere and magnetic field protect us from the majority of this radiation. But in space, humans are exposed to radiation from cosmic rays and solar flares, which can have a range of negative effects on the body. One of the main concerns with radiation exposure in space is the increased risk of cancer. Radiation can damage DNA and other genetic material, which can lead to mutations and the development of cancer. It can also cause damage to the eyes, leading to cataracts, and to the immune system, making it more difficult for the body to fight off infections. In order to mitigate the effects of radiation, scientists are working on a variety of strategies. One approach is to use protective materials that can shield astronauts from radiation. These materials can include water, plastic, or other substances that are effective at absorbing and blocking radiation. Spaceships and habitats can also be designed to provide additional protection from radiation, such as incorporating shielding materials into their construction. Another approach is to develop drugs or other treatments that can repair DNA damage caused by radiation. For example, scientists are exploring the use of antioxidants and other compounds that can help to reduce the effects of radiation on the body. Other potential treatments include using gene therapy to repair damaged DNA or developing drugs that can stimulate the production of new healthy cells. In addition to these approaches, scientists are also working on developing new technologies that can better monitor and track radiation exposure in space. This can help to ensure that astronauts are not exposed to levels of radiation that could be harmful to their health. Technologies like dosimeters and radiation detectors can be used to measure radiation exposure and provide real-time feedback to astronauts and mission control. Despite the challenges presented by radiation, there is reason to be optimistic about the possibility of long-term survival in space. Scientists and engineers are continually making progress in developing new technologies and strategies to mitigate the effects of radiation and other challenges of space travel. With continued research and development, it may be possible to create a safe and habitable environment for humans in space, allowing us to explore and colonize new worlds beyond Earth. The lack of gravity in space is another major challenge to long-term survival. Our bodies are adapted to live in a gravitational field, which helps to regulate many physiological processes. In the microgravity environment of space, however, our bodies undergo significant changes that can lead to a range of health problems. One of the most well-known effects of microgravity is bone loss. Without the constant force of gravity, our bones do not have to work as hard to support our weight, leading to a loss of bone density. This can increase the risk of fractures and other injuries, and can make it more difficult for astronauts to carry out their duties in space. Muscle loss is another major concern. Without the constant force of gravity, our muscles do not have to work as hard to maintain our posture and move our bodies. This can lead to a loss of muscle mass and strength, which can impair physical performance and increase the risk of injury. Cardiovascular changes are also common in microgravity. Without gravity to help circulate blood throughout the body, fluids can pool in the upper body, leading to a range of cardiovascular issues. This can include changes to heart function, decreased blood volume, and a decreased ability to exercise. In addition to these physical changes, microgravity can also have a range of psychological effects. Isolation, confinement, and the stress of living in a confined space for extended periods of time can all take a toll on mental health. Despite these challenges, there are several strategies that can help to mitigate the effects of microgravity. One of the most important is exercise. Astronauts on the International Space Station are required to exercise for several hours a day, using equipment such as treadmills, stationary bicycles, and resistance machines. This helps to maintain muscle mass and bone density, and can also help to counteract cardiovascular changes. Another approach is to use resistance training to build muscle strength. This can include exercises like lifting weights or using resistance bands, which can help to maintain muscle mass and prevent muscle atrophy. If humans could survive in space, it would open up a whole new world of possibilities for space exploration. Currently, the longest mission in space was the year-long stay of Scott Kelly on the International Space Station. However, if humans could survive in space for longer periods of time, we could potentially send astronauts on longer missions, such as a journey to Mars or even interstellar travel. Long-term space missions could also have numerous benefits for Earth. For example, we could potentially mine asteroids for valuable resources, such as rare earth metals and water, which could be used to support life in space or transported back to Earth. We could also use space as a platform for scientific research, studying everything from the effects of radiation on the human body to the formation of planets and galaxies. In addition to the scientific benefits, long-term space missions could also have political and economic benefits. If humans could survive in space, it would open up a new frontier for exploration and could potentially lead to a new space race between nations. It could also lead to the development of new industries, such as space tourism or space manufacturing, which could create new jobs and boost economies. However, the idea of humans being able to survive in space also raises ethical questions. For example, if humans could survive in space for extended periods of time, what would happen to their mental health? How would they cope with the isolation and confinement of long-term space missions? These are important questions that would need to be addressed before long-term space missions become a reality. In conclusion, if humans could survive in space, it would be a game changer for space exploration and could potentially lead to a new era of discovery and innovation. While there are still many challenges to overcome, the progress we have made in recent years suggests that this once impossible idea could one day become a reality.